Good morning to all. Myself Muniraju Naidu, Assistant Professor, Department of Computer Science and Engineering, working at Institute of Aeronautical Engineering. So in this video, I am going to discuss about structure of the page table in operating system. So from the previous video, you know that what is paging and what is the importance of paging, how the logical address is generated into the physical address. So now coming to this structure of the page table. So basically the data structure that is used by the virtual memory system to store the mapping between physical memory and logical memory, that is known as a page table. So now I am discussing about this page table. So the data structure which is used by the virtual memory system to store the mapping between physical address as well as the logical address, that is known as the page table. So this particular page table which provides the corresponding page number where that particular page is supposed to be stored. This particular page table which provides the corresponding page number where the particular page is supposed to be stored. So for example, if you take simple characteristics of any particular page table, what are the various characteristics of a page table? Characteristics of a page table. First of all, page table which is stored in the main memory. Page table which is stored in the main memory. Then second one, the number of entries in the page table. We have a number of entries in the page table. Those are equal to the number of pages. Number of entries in the page table, those are equal to the number of pages the processes are divided into. That is the second characteristic. And third one, each and every process has its page table. Each and every process has its page table. Then fourth one, page table base register PTBR. Page table base register which holds the base address for the page table. Page table base register which holds the page table's base address. PTBR which holds the base address for the page table. So this is the introduction about the page table, right? Why we go for this particular structure of the page table. So the structure of the page table, in the sense, these are the techniques which are used for structuring the page tables. These are the techniques which are used for structuring the page tables. Those are hierarchical paging, hashed page tables and inverted page tables. Right. So let us look into this one by one. Right. Hierarchical paging. So this particular hierarchical paging, which is also known as a multi-level paging. Multi-level paging. So hierarchical paging, which is also known as a multi-level paging. This multi-level paging is a type of paging where the logical address space is divided into the multiple page tables. You know, hierarchical page tables, right? So just a parent-child relationship. Hierarchical paging, which is also known as the multi-level paging. This multi-level paging is a type of paging where the logical address space is broken up into the multiple page tables. So this is multiple paging or hierarchical paging is one of the simplest technique. For this, here we need to describe the 2-level page tables or 3-level page tables. So multi-level paging or hierarchical paging will simply break up the logical address into the multiple page tables. So this is a simple technique for a 2-level page table or a 3-level page tables. See, this is the 2-level page table scheme. 2-level page table scheme. See, this is a outer page table. This is a outer page table. This is the basic page table and how those are mapped into the physical memory. See, outer page table. Let us take only this particular one. So this particular part, so these are represented, for example, the page numbers are from here 0000 to 1000 like this, right? So this particular page table which consists of these many number of pages. So 1 to 500, 1 to 500, right? So we know that how to map the logical address to the physical address, right? See, 1 here and 500 is somewhere. So that is the 2-level page table scheme, or we can call it as a multi-level paging or hierarchical paging, right? So let us take an example to explain about this 2-level paging. Here the logical address is divided into the page number and page offset. So that is the common thing in case of paging. Whenever the processor generates any new process, automatically it creates a logical address. That particular logical address which consists of page number and page offset. So let us take here we need to consider 32-bit machine. 32-bit machine. So here the logical address is generated into the page number and page offset. So among these 32 bits, only 22 bits for page number and for offset 10 bits. Right. So what happens? This is a 2-level paging scheme. Since the page table is paged, again the page table is paged. So this particular page number which is again divided into the page number and page offset. So this is the page offset and this is the page number. So 12 bits for page number and 10 bits for the page offset. So here we need to mention these logical address as a 2-level paging scheme like this. See, initially the page number we can call it as the logical address of 32 bits which are divided into the 2 parts. One for 10 bits for the page offset, remaining 22 for the page number. So this is a 2-level paging. Again, this particular 22 bits are again divided into the 12-bit page number and 10 bits for the offset. So according to the operating system, here Pi which represents an index into the outer table and P2 that is the displacement within that particular page of the outer page table. Right. So this is the example for 2-level paging, and how the address translation is performed here in case of 2-level paging or hierarchical paging. See, the logical address which is divided into the 2 parts initially, that is a page number and page offset. So this is a 2-level means again the page number which is subdivided into the 10 bits for displacement and 12 bits for the page number. So that is represented P1, P2 and D. D is the constant, that is for displacement. So these are the 2 pages, right? See here, P1 which acts as an index to the outer page table. P1 which acts as an index to the outer page table. Now this is page of page table. So again here we can call this is the page of page table. Finally, this is the displacement. So that is here the address translation scheme is from logical address to the physical address, right? So let us take a next level, that is a 3-level paging scheme. 3-level paging scheme. So for this 3-level paging scheme, here we need to consider like this. See, for example, if we take the 64 bits, right? See what happens here. Outer page table which stores 42 bits, inner page table stores 10 bits and the displacement 12 bits. Right, 42 plus 10 plus 12, 64. Then page of page table. So again this particular 42 which is subdivided into the 32 as well as the 10. 32 as well as the 10. So that represents that second outer page table 32 and outer page table 10, inner page table as it is 10 and offset is 12. So like this the hierarchical page table is divided into the various page numbers as well as the page offsets. Right. So what happens according to this multi-level, or we can call it as a hierarchical paging. So either 2-level or 3-level page of page tables are generated. So next one, hashed page tables. Right. So this particular hashed page tables method which is used to handle the address space which are greater than 32 bits. Hashed, when we can use this particular hashed page tables. So in real time scenarios, whenever this particular hashed page table method is used to handle the address space which more than 32 bits. So what happens here, the virtual page number which is hashed into the page table. Virtual page number which is hashed into a page table. So any page table which contains a chain of elements hashing to the same location. So that is, there is a chain of elements, those are hashed into the same elements. So these elements consist of virtual page number and the pointer to the next element, and the value of the mapped frame. Excuse me. Yeah. The value of the mapped page frame. Right. So simply say that hashed page table, that is a method we need to use whenever the logical address space is larger than 32 bits. Right. So if so, in this particular hashed page table, there is a chain of elements hashed into the same elements. So that particular elements which consists of first one, virtual page number, second one, the pointer which is next to the elements in the list. And the third one, the value of the mapped page frame. So something like cluster tables also, which are just like similar to our hashed page tables, but those cluster tables are used for 64 bits, whereas our hashed page tables which are used for just greater than 32 bits. Right. So the virtual page number which is hashed into the page table, again the page table which contains a chain of elements which are hashing to the same location, and these virtual page numbers are compared in this chain searching for a match. If that particular match is found, then the corresponding physical frame is extracted. So see, this is the example for hashed page table. See, this is the logical address. Logical address is divided into the physical, we can call as a page number and page offset. Right, this particular page number acts as input to the hash function. Now this is the hash table, chain of elements. So initially the elements which consist of virtual page number and a pointer which points to the next element in the list. See, which points next elements in the list. And then the value of that particular mapped page frame. Right, see here, this is the physical address. So that is a hashed page table. Right. Next one, inverted page tables. See, inverted page table is a combination of page table and a frame table. Inverted page table, that is a combination of page table and frame table. Right? So here there is only one entry for virtual page number and real page of memory. There is only one entry for virtual page number and real page of memory. Each and every entry which consists of the virtual address of the page that is stored in that real memory location. Each and every entry consists of the virtual address of the page that is stored in that real memory location with information about the process that owns that page. Right? So what happens here? This method, inverted page table method, which decreases the memory needed to store each and every page table. Right? So because here each entry consists of virtual address of the page stored in the real memory location with that information about the process that owns that particular page. So based on this inverted page table method, which decreases the memory required to store each and every page table, but at the same time it increases the time needed to search that table whenever a page reference occurs. So it increases the amount of time needed to search the table for a page reference. Simply say that page reference. So use the hash table to limit the search to one or a few page table entries. So that represents that inverted page table. See here, this is the inverted page table architecture. Inverted page table architecture. See, the processor which generates the logical address space. We know from the concept of inverted page table that is a combination of page table and a frame table. Page table and a frame table. So process ID, page ID, page number and page displacement. Right? See, there is one entry for each and every virtual page number and real page of that particular memory. Right? So there is one entry, that is a process ID and page number, there is a page number, and we need to find out this particular element I. Right? So we need to search for that page number. If it founds, then we need to access that particular address. So that is the inverted page table. There is only one entry for this particular virtual page number and real page of memory. So what happens with the help of this particular inverted page table mechanism, which decreases the memory required to store each and every page table. If it is fine. But what happens at the same time, it increases the amount of time requires to search the table, because that particular table is having a huge amount of information. So that describes that inverted page table architecture. Inverted page table architecture. Now coming to advantages and disadvantages of paging. Right? So we know paging is one of the important concept in memory management. Particularly, paging stores the pages in a non-contiguous manner. So with the help of this particular paging, always the processor generates the logical address. That particular logical address is mapped to the physical address. So paging is a simple technique which is used to implement and assumed as an efficient memory management technique. So that is a basic advantage. Paging is a simple technique to implement and assumed as an efficient memory management technique. So this particular paging mechanism which reduces the external fragmentation. External fragmentation. Right? So we know what is meant by external fragmentation. So what happens in case of paging? the logical memory, which is divided into the fixed size blocks of same size pages, whereas the physical memory is divided into the fixed size blocks called as a frames. So these are the fixed sized. So what happens here, each and every frame which consists of 100 KB. So whenever the page wants to execute, for example, the page capacity is 90 KB, automatically it fit into this particular frame and executes. But what happens here, 10 KB is wasted. 10 KB is wasted. That is, we can call as the paging technique which suffers from the internal fragmentation. It reduces the external fragmentation, right? So that means we don't want in a contiguous manner to store any particular page. So paging which reduces the external fragmentation but still suffers from the internal fragmentation. Due to the equal size of the pages and frames, swapping becomes very easy. Due to the equal size of the pages and frames, swapping becomes very easy. So we know swapping from the backing store to the primary memory. But the drawback is here, the page table which requires extra memory space. Page table which requires extra memory space, so may not be good for a system having small RAM. So that's why whenever we need to purchase system, always we need to compare with the primary storage devices as well as the secondary storage devices. For example, if you take 4 GB or greater than 4 GB RAM, then automatically you can go for this secondary storage minimum of 1 terabyte hard disk or a minimum of 500 GB. Because based upon your another important parameter, processor also, either i5 or i7. So based upon your processor, the processor needs to execute more number of applications. For example, if you take i5 3.6 gigahertz, right? So this particular processor is capable of executing more number of applications. We know all the applications are stored in RAM. From the RAM, it executes all the applications. So automatically your RAM capacity is also greater than 4 GB. Right? How fastly this particular RAM accepts the information from the secondary storage devices, right? So that depends upon the configuration of these three parameters. So these are the advantages and disadvantages of paging, right? So in this video, we discussed the structure of a page table. We have three categories. One is hierarchical page table. Second one is inverted page table, and third one is hashed page table. Hashed page table, right? So I hope you understand this structure of page table, right? So now come to this paging. I hope the paging concept is understood, right? What is meant by paging? What is the importance of paging, and what is the paging hardware? Paging hardware again without TLB and with TLB, translation look aside buffer, and the paging concept is explained with an example. Now structure of page tables, right? So those are hierarchical paging, hashed page tables, and inverted page tables. Guys, follow IARE YouTube channel. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.